All right, GAC students, Algebra 3, hope you're doing well. Welcome to Coach J's What It Do Test Review. Hope you're having a great night tonight. Again, just some reminders today of some things that you can help me with. First thing is occasionally, especially when we do one of these reviews, sometimes there's maybe a lag on your end, or maybe for some reason my connection's not working. If at any time that happens, please make sure that you let me know and we'll go from there. Also, if you could, text me in at my number 770-757-2240. When you text in, what we'll do is we'll use that to be able to go through any questions that you may have. I already see viewers that are popping up right now. As you text in right now, I wanted to go over some questions that I feel like everybody will have regarding the review. And we're going to go over that as well. And I just had one there. First one, number 20. Awesome. And when you text in, make sure, if you could, just put your name out there, just so I know who is here, and that would be beneficial to me as well. A lot of people already have in my phone, but just in case. All right. So let's go over a couple questions before we get to our first one on number 20. First things first, we want to make sure we kind of figure out two example problems, all right? And what they're going to say, and this, by the way, is not on the this is not on the review, so you really want to make sure you get this down, all right? All right. Now, in both of these scenarios, scenario 1 and scenario 2, we're going to ask ourselves what the domain is for both of these. Now, remember, there's only two things, and actually I could give a third one here. If I had a third one that looked like this, x squared plus x, we could have that one as well. Well, remember, there's only two types of domains that are limited as a result of the equation here. And that's when we have something in the denominator, and then also we have something in a square root as well. If we have something that says x squared plus x with nothing in a square root, nothing in the denominator, then we know this will be all real numbers, or we could say from negative infinity to positive infinity in interval notation. Now, if we ended up coming, and I'll actually change this color here, if we ended up coming to either of these two, it's important to note that inside of a square root, that everything that's inside has to be either greater than or equal to 0. So whatever's inside the square root on the outside, we're going to set this, we say equal to 0. It's really greater than or equal to 0. And then we can solve from there. So when I add 1 on both sides and add 1, we'll have 2x is greater than or equal to 1. And then when I divide by 2, I get x is greater than or equal to 1/2. Now, if that's the case, which we know it's true in this case, we know that if it's greater than or equal to, we'll have 1/2 to infinity, because if it's greater than or equal to, we know that that's got to go to infinity there, or has a possibility of going there. And then we also know that this 1/2 is going to be a bracket because of the equal sign right there. All right, another important thing to note is that when I have x squared minus 4, we could factor this to x minus 2 and x plus 2. Now, a little bit different from the square root. Inside the square root, we set it greater than or equal to 0, where on the denominator here, we set both of these on the bottom. Now, again, I don't care about the top. This could have an x on top. This could have x squared on top. It doesn't matter. The only thing that I care about is what's on the bottom. So when I look at that here, I notice that x minus 2 and x plus 2 are there. So I set both equal to 0 separately to where x is equal to 2 and negative 2. And really, when we find that out, that means x cannot be equal to those values, because if it did, it would make a 0 on the bottom, which would make it undefined. So a sufficient answer would be x is not equal to 2 or negative 2. And again, same thing goes down here. Because there's no square root or anything in the denominator, we know that we will have all real numbers. Now, as I go through any of these questions, if at any point you are struggling with one, please text me so we can go back to those questions again. Then we'll go from there. All right, sweet. Let's check the viewers right now. Right now we have 8 viewers. Thanks so much for showing up tonight, y'all. That really, really means a lot. It really does. So let's keep going. probably important to note as I erase this next one before I get to number 20. Tell you what, if you next to your next to the first problem there, okay? Next to the first problem, so on the test, I'll have number 1 and I'll list it and go from there. Next to your first answer, if you put a Michigan M right next to it, doesn't have to be perfect like this, but if you've watched this podcast, then you know. If you do that, then I'll give you a bonus point on the test, all right? I'll give you +1 on the test. I know it's not much, but it's just a thank you for coming to the podcast. Also, please do not share this with other people because if everybody does it, then I know that something went down there. And so, again, this will just be between me and those that are in this study session. All right. I also got number 2 here. We're going to get to number 2 here in a second. Let's go to number 20 first. That's a really good one. And then we'll go from there. All right. Number 20. Write an equation with a given condition. Okay. It passes through 1, 6. And also passes through -1, 2. All right. So it passes through both of those. And we're trying to find a line. And let's do this. Let's put it in point-slope form first. Now, a couple things to know. You're going to need to know slope-intercept form. You're going to need to know point-slope form. And then you're also going to need to know how to find the slope, which was y2 minus y1 over x2 minus x1. Those 3 are very important for tomorrow. So make sure you kind of know those as well. If you struggle with the second one, just remember M stays the same and we'll throw out B. And when we bring it down to point slope, just put x minus x1 in the x spot and y minus y1 in the y spot. All right. Now, the first thing we've got to do within both of these points is we've got to find the slope. So let's do y2 minus y1. So here's y2, here's y1, here's x2, here's x1. All right. So we've got 2 minus 6 all over -1 minus 1. Now, as I plug in 2 minus 6 equals -4, and -1 minus 1 equals -2. All right, -2. And also got those texts there, by the way. Thank you so much. We're going to go to 2 and 4 through 6 here in just a second. All right, so right here, as I simplify, I get my slope is 2. Now, remember that when I get 2, this 2 should be plugged in. Plug it in, sponsored by Glade today. So when I plug these values in, it will go right straight in for M. Now, let's put it in point slope form first, and then we can go to slope intercept. So right now, we've got y minus y1 equals 2 times x minus x1. Now, as I plug in, the important thing to note is that I can take either of these 2 points. Let's just do 1 and 6 since that's easy. So when I plug it into the bottom, 6 will go in for the y1, and x1 will be 1. So 6 will go in for the y1, 1 will go for x1. So it should look like this. Y minus 6 equals 2 times x minus 1. Now that right there would be in point slope form. And if you really wanted to get into slope intercept from this point, again, you could do it the way that we taught it in class, but you could also distribute the 2 to get 2x minus 2, and then add the 6 to both sides on the y minus 6 side. And when I add 6, I should get y equals 2x plus 4, okay? And right there, that's the line that we're talking about in slope intercept and in point slope form. And again, that's how I find the slope up there as well, okay? Note that there was a lot with that one, but hopefully that was helpful for you as we prepare going forward. Another thing to kind of just keep in the back of your mind, other than the formulas as well, is just, hey, what's the problem asking for? And anytime I have 2 points, I'm going to find slope first, and then you could plug it in and do what's easiest for you following that as well, okay? All right. Hey, as I go to number 2, if someone could, just real quick, on that one, just tell me how the connection is. I think it's good because I haven't had anybody say anything. But if someone could just text it out, usually if it's good for one, it's good for all. And so we'll get it and go from there. So, but yep, we'll just make sure we've got it there and we'll go forward, all right? All right, so let's do this. Let's go clear that. Perfect. Awesome. Connection's great. All right. Thank you so much for y'all for responding to that. All right. Now, on the next one, number 2, it gives us multiple points. Now, remember, when we talk about domain is left to right and range is low to high. All right. What I want you to do right now in front of your screen is I want you to get up right now and do the dance. Here we go. Ready? Domain is left to right and range is low to high. If you didn't do it right now, you might fail the test. All right. Don't worry about what your parents think or anybody else thinks. Just do it. Okay. Just do it there. All right. So as I was saying, when we talk about points, we have multiple points here. And instead of having a continuous graph, what we have now is we're trying to find the domain and range of something where just points have been given. So as I move forward, the important thing to know is that anytime I have, oh yeah, I'm sorry, and the dib dab dibby dab. Sorry about that, y'all. Just got that. So as I look at this, we know we have the X and the Y for our points, all right? So as I focus in on this, sorry, I'm laughing at the text. I'm looking and seeing, is my X's, are they repeated? Because if my X's are repeated, then we know we don't have a function. However, if my X's are unique, then I have a function. And so in this case, it would be yes, that X is a function of Y, all right? Or Y is a function of X, I'm sorry. So as I look at for my domain, usually we have it like an interval notation, but because in this case we have 3 separate pieces, we would say my domain is 2, 3, and 1. And it really should be in order. I apologize. It should be 1, 2, 3. You could put it like this: 1, 2, 3. You could do that as well, all right? So that would be our domain. Now our range would be, in this example, would be the Y, so 10, 500, pi, all right? And again, that's what we would have going forward for our range as well as our domain. And that's what we would be looking for. Look at number 3. You'll notice that on that one, it has 12, 14, and 12 for my X's. So here's my domain right here. Remember, if my domain is repeated, okay, meaning my X is repeated, this would not be a function. And so 3 would not be a function in that scenario, all right? Let's look at 2, 3, and 4 here. And I'm going to kind of put this one out. This one's a good one. This is good stuff right here, y'all. I don't care what y'all say. This stuff gets me excited right here. I mean, there's nothing more I would love to be doing right now. Right here, helping y'all out with some math. Gotta love it. All right. Now, in this example, the important thing to note is what is this graph, what is this graph, and what is this graph? Now, if you remember parent functions, which we discussed at the beginning of the unit, we discussed that if we have something that has X in it, we can actually put this in regular form by saying Y equals negative 2X plus 8. All right, that's kind of the better way. And same thing, Y equals now negative 3X squared plus 14. This one's a little bit different. You can kind of note with the Y squared, but if I were to subtract X, it would be negative 2X plus 6. Now, this is where a lot of people struggle. I've got a square root to get Y by itself, and that equals Y equals plus or minus the square root of negative 2X plus 6. Now, you don't actually have to do this part. The important thing to note is what is occurring to the graph, right? Now, if Y is by itself, we can note what is happening to X, and that could determine what the graph is. For instance, since this is an X by itself, we can assume that it is a line that's going either left to right, sloping up, down, or whatnot. Now, if it is X squared, we can note that it's either maybe a parabola up, it also could be a parabola down, but either way, we know what that picture looks like. And Y squared, when we see Y squared just means that we have a parent graph that's a parabola sideways. So either way, I'm looking and seeing, does my vertical line test as I go from left to right, does it only pass once? And if it does, then it's a function. So just like Dora the Explorer right now, I want you to yell in the screen, is this first one, is it a function? Yell at the screen right now. You're not too cool. All right, you're not too cool. All right, you're correct. Very good. This first one would be a function, okay? Would be a function. So we would say yes for that line, because it does pass the vertical line test. Now look at the second one. The second one in this example is a parabola, either up or down. Positive, if it's positive, it goes up. If it's negative, like in this situation, it would go down. But it doesn't matter. As I move from left to right across that graph, it would only touch once. All right? All right, I love it. Just so you know, we have students that are so serious right now that they're yelling at Panera. All right? By the way, I'm not going to mention who that was, but if you're at Panera right now, I want you to do the dance right now in the middle. Go ahead. Nope, you're not too cool. Don't think, just do, okay? All right, so coming back to it, within the first one and second one, we know that those are both functions. Now, what about the third? Is the third one the function? I want you to yell it out. You're correct. The answer would be no, because as I did the vertical line test from left to right, it would cross twice on that vertical line, therefore failing the vertical line test, making it not a function. So it would be yes for 3, for 4, yes for 5, and no for 6. And that's how we would do those examples there. Okay? All right. Awesome. I've got people dabbing at Panera. I've got people doing all sorts of stuff. I love it. Absolutely love it. All right. Let's see here. Connection's great. Thank you, JP out there. Don't want to say your name. Appreciate you for saying that for me. 4 to 6, we got that. We are G to G. We are Gucci over here. Number 22, I like 22. And then I got B-dub with 32, okay? Hey, do this just for a second. I want you to look at 22 real fast. I actually lost connection in the bamboo tablet, okay? Sometimes it runs out of ink, so you got to help it out a little bit. We're going to look at 22 here in just a second. I want you to begin on it. Remember, parallel means what? Yell it out, just like Dora the Explorer. Parallel means what? That's right. The slopes are the same. Perpendicular means that from one slope to the other, that we take the slope and we take the reciprocal opposite. Okay, reciprocal opposite. So we're going to hit up number 22 here in a second. Then we're going to help B-dub out there. And we're going to hit up 32, okay? 32 as well. So hold on tight. Give me just a second, and I'll be right back. All right? Thank you. I just tripped. I apologize. Just tripped. Sorry. Sorry about that, y'all. Hopefully you didn't hear that too bad. I actually tripped over my Mac. I apologize. Again, hopefully the connection's good there. That was really embarrassing. It's all right. We're going to get this hooked up here. And as I do that, let's see, 22. 22 is a good one. You know, one thing to note is I always put what is given in a problem. You know, when I approach a problem, one thing that always helps me is let me make sure here. Yes, I just got a text here. Want to make sure I'm clear. Number 6 was not a function. If I said yes, I apologize. Number 6 was not a function because it is a sideways parabola, and that sideways parabola obviously fails the vertical line test, and so that's what we were inferring on that side. So I apologize for that. Hopefully I didn't confuse anybody on that, but I wanted to make sure I clarified. All right, now we're back at it. Again, hopefully the connection's good. I did hit my Mac, so I want to make sure it is, but it should be there. It gives us the following information, all right? So we have this point traveling through y equals 1/3 x plus 4. Now, we also note that it is perpendicular. Now, remember, that's the perpendicular gang sign, and this is like the parallel gang sign, all right? So, again, maybe if you don't remember it, maybe you could get a tattoo of it just so you can, you know, maybe right on your wrist or something so you don't forget that, all right? So, let's say this. Let's say I look at this specific problem. The question is what is it asking for? Let's say it was asking for parallel. We know that in the line, if we were asking for something that's parallel, we would plug the same slope in for the equation. And to solve for the missing b, we could plug in -3, 6, knowing that this is going to pass through -3 and 6. Now, if it's perpendicular, what do we do? And we kind of said this earlier, for those of you who yelled it in Panera. We could take 1/3, we could flip it and change the sign. So that 1/3 becomes 3. Really, if we make it negative, now becomes -3. So y equals -3x plus b. All right, so here's our equation right here. So if y equals -3x plus b, that's our equation. And now what we want to try to do is solve for the missing parts. Now, x and y are going to remain there, right? They're all by themselves, and they want to stay there. But b is all alone. We want to put a value for that. Remember, what does b stand for? B stands for that y-intercept. And so we can find that y-intercept by plugging -3 in for x, as well as 6 in for y. So as we go, it's 6 equals -3 times -3 plus b. So when moving forward, we have 9 plus b, and we could simply solve by subtracting 9, where b is equal to -3. Now plug -3 back in for b, and now you've got your equation. Y equals -3x minus 3, and that right there would be the answer to our perpendicular line concerning or with y equals 1/3 x plus 4. Remember, perpendicular means that it creates a 90-degree angle when they intersect. And so just so we know that make it clear, that's how we would write it. Now, if we were asked to graph it, remember -3 means that we start at -3 low, right? And -3x means we go down 3 to the right 1, okay? Down 3 to the right 1. And we could actually draw it just from that alone. And there you go. There's our graph right there. And just in case you were supposed to graph that on that one as well. All right. Hey, I'm going to do number 32, I believe. I think Brandon or B-Dub wanted me to do that. If you got another question, throw it out there at me. Text me out there. I know I've got tons of people, hundreds upon even some thousands of people over in Sweden right now that are watching me live in their classroom. So welcome, Swedens. Thank you so much for showing up to class today. So thank you for that. And those at GAC, thank you for coming as well. Appreciate that. Thanks for joining us. All right. So as we solve for x here, one thing we got to do is put everything to one side. So we like x squared positive. So let's subtract 8x and subtract 3 to both sides. Now, a lot of people, when doing that, understand that we get everything to one side, but notice we can't subtract x squared and x because those are not like terms. Just be careful on that. You shouldn't do that, but just in case, I want to make sure we get it from there. All right, so now what I need to do is I need to figure out what could be factored out to have this come back to, if I were to distribute, to come back to what's on the top. Now, one thing that people have done is do the A times C method, and that would work. But I'm going to do the check and guess method just for those people that like to do that as well. So what I'd like to do is just put the factors of 3, and we know that it's going to be either 1 or 3, or a -1 and -3. Now, probably it's going to be positive and positive, largely because it's with that x squared. So we're just going to put 1 and 3, or we'll just say x and 3x right there, okay? Now, the last two terms are going to have to distribute to be equal to -3. So we could have -1, 3, or +1 and -3. So as I plug in, I could plug 1 in and just say, okay, this is -1, this is +3. And as I distribute, I notice I get 3x squared, okay? But then I notice x times 3 is 3x. -1 times 3x is -3x. And did I do that right? I think I did that right. -1 times 3 is -3. And as I look at that, I notice that's probably not going to work. So let's try this another way. Let's flip-flop those and say x plus 3 and 3x minus 1. Okay? Now, as I notice this, I kind of, and I'm even trying to see what could be done here. I noticed that as I distribute, this could get 8x, but it'd make it positive. So we kind of check and guess again, and this time what we're going to do is we're going to switch the sign. So now we have 3x plus 1, and now I've got negative 3x squared. Negative 3 times 3x is negative 9x, and 1 times x is positive x, again with the 3x squared and negative 3. And when I combine this, I get negative 8x, which gets me back to the top. So this right here is sufficient for how we could factor the following problem. Now, the issue is since it's set equal to 0, we're not done. So what I've got to do is find out what is x equal to. So I set x minus 3 equal to 0, and 3x plus 1 equal to 0. And what I'm going to do is I'm going to add 3 to both sides to where x equals 3. And I'm going to subtract 1 and then divide by 3 to get x is equal to negative 1/3. Okay? So those two right there, x equals 3 and x equals negative 1/3, are the correct answers for this problem. I know I took it a longer way. Some of you probably prefer A times C, but I want to make sure that we did it in a number of different ways for those that need it as well. Okay? All right. I'm out of questions right now. I know there's probably more out there by maybe some of you. I know 8 viewers. Man, that's quite a few for tonight. I really appreciate you for coming out, and I know more are going to come back later on. But if you got another question, feel free to text me. While you text me, what I'm going to do is I'm going to start at number 1 here and just kind of walk my way down through it. Numbers 1 through 3 are ones that we've already kind of gone through there. Again, domain was with x, and make sure that the domain or the x values are not repeated. Otherwise, it's not a function. We went through 4 through 6 and went through those graphs as well. Evaluating a function is very important. One thing to note is on number 8 with 3x squared minus 5x plus 2. On letter C, it says g of x minus 1, meaning we plug x minus 1 in for x. So we get 3 times x minus 1 squared minus 5 times x minus 1 plus 2. And so with the x minus 1, we know that it's multiplied by itself and go from there. So important thing to note here, please make sure you distribute. Okay, don't just multiply the first 2 and last 2. This would be x squared minus 2x plus 1. And I did that in my head, but you get the idea. And then you can distribute 3 across all 3 and then kind of go from there, all right? All right, I did see number 14. I will get to that one in just a second here. It's a great question on that one. That's a good one. Another thing to note, number 9 is another good one. And number 10, we'll go through number 9 real quick, just to make sure we've got that one on there. This one kind of has this thing here where it says if x is greater than or equal to 4, or if x is less than 4, okay? And let's see one like B, for instance, is what is g of 0? Well, is 0 greater than or equal to 4, or is it less than 4? It's less than 4, so I'm going to input 0 in for the second equation to where 4 minus 0 equals 4. And again, that would be our value for that, and that's just an example of that one there. Number 11, number 12, make sure we look at the vertical line test. 11 would be a failed vertical line test because it hits twice. 12 would pass it, so it would be a function. So 11 is not a function. 12 is a function there, okay? On the test tomorrow, actually, I'm going to come, actually, we could change it up a little bit. On the test tomorrow, it's very important to note that if I give you a function, this goes to the left 3 and down 2. I'm looking at number 14, by the way, okay? Or BTW, as many of you say in text language, all right? So as these endpoints keep going, notice that there's no dot. On the test, I'm going to give you these arrows. I know they're not there, but it's going off of the graph, so we're going to assume that it is going to infinity and negative infinity. So in this example, we have 4, really 5 things we're trying to find. Domain, range, interval of increasing, decreasing, and constant. And I kind of put it as that so we can kind of see it there. Now, if domain is left to right, we note what is the furthest left value. Now, domain is on the x, right? So x, right, and range is on the y. So the furthest left value will be negative infinity because it keeps going to the left side, whereas the furthest right would be positive infinity. So we're going to put positive infinity there. Now for my range, I go low to high. So my low to high, my low is -2, and my high is infinity, okay? Low to high. And then you could say kill them, dib-dab, dibby-dab, right? Now, one thing is wrong with this picture, okay? I've got everything right. I got all my numbers right, but there's one thing wrong. And some of you have probably already been yelling at me in Panera right now, not saying any names. But that -2 should have a bracket because it's like a dot that's filled in on the bottom. So since the value hits it, we're going to keep it as a bracket there, just like so. Now, interval of increase and decrease and constant. As I move from left to right on this graph, what is happening? So as this, again, roller coaster comes this way, right? Okay. What is occurring? Well, as it goes from, and remember we're talking about the x-axis, but we're also saying what is it doing? It's decreasing from negative infinity all the way to -3, okay? So that is where it's decreasing. It's decreasing from negative infinity to -3. We keep it in parentheses. And then all of a sudden from -3 all the way to the right to infinity, that is increasing, and it is constant none of the time. You could put nacho cheese. You could put nunya. You could put not, or whatever you want to say on that, okay? Now, if I had multiple ones, let's say it increased. Now, this is separate, right? Separate, separate, separate. Like, look at number 15. 15 increases from negative infinity to -2 on the x-axis. And it also increases from 3 to infinity. Increases twice. Make sure you put that union in there to denote that it's either this or this, okay? And so that's a good one on that, all right? I do have a help session in the morning, so come up, show early. We will go from there. I may have a couple people come in and present a project, but for the most part, people are going to be in there. We can help each other out. Even if I'm listening to the project, I'll have some people in there that we can kind of collaborate together. So feel free to come on in. We'll go from there. So, but I think I may have 1 or 2 projects just to kind of keep you aware on that. All right. All right. Great job there. We did one just like 17 and 18. We find just the slope. That's a pretty easy one. Number 19, if we did number 20, number 19 should be easy because number 19 just gives you the slope there. We did 20. 21 talks about parallel. One thing to note is that anytime I have, and let me come back here, anytime I have let me get a different pen here. Anytime I have like this is the one thing I think we need to just remember. Isolate y. So let's subtract 3x and let's add 9 to both sides. And when we do that, we get rid of that to where y is equal to now -3x plus 9. And on number 21, it asks for what's the parallel. Well, parallel means same slope. And so we can plug in. And now we've got to solve for b. Well, we know it passes through this point. And so just like before, we'll plug 4 in for x, -7 in for y to solve for b. But just giving you a heads up, isolate that y, and that will be a huge help there. Another thing to remember is y equals like 2. That means that it's going to be a horizontal line going left and right across 2. If it's x equals like -3 here, that means that on this one, it'll be we'll go to -3. It'll be a vertical line there. Remember, vertical line is undefined. Think of it as a ski slope. There's no way you could go down that. It's undefined. Whereas the slope on this one, if I skied this, would be a slope of 0. So that's a good way to remember that one there. Trying to think, all these other ones are just graphing lines, and man, a lot of these we did in class. Look at the backside exponentials, all that jazz, and I think a lot of that you'll be G to G on. I'm going to do this. I'm going to hold off just for a second. If you have any last minute questions, I'm going to give 1 more minute for you to put that question in. Look, I'm so grateful that y'all have been here today. I'm so grateful even that you were dancing through Panera in your house or yelling in your house. I know that your effort is going to go a long way for your preparation for the test. Again, tomorrow will be part 1. Make sure you know the whole review. The review will be due on Tuesday, so you can use it to study on Tuesday. However, I'm going to check it tomorrow, so make sure you bring that in. Other than that, I just look forward to y'all dominating this test. I feel confident that y'all will with proper preparation and focus. I'm going to hold off for just a couple more seconds. All right. It's Coach Jay signing off. I hope you have a fantastic night. Thank you so much again for making me, having me a part of it. 9 viewers tonight and counting. I know we're going to increase and go from there. But I love y'all, care about y'all. See y'all tomorrow, and let's get after the test. See y'all.